level biology, well, why not check out my group tuition sessions? But what I thought I'd do today is show you a little flavour as to what I have to offer. So you might be asked about a mitochondrion, and you should know that this is the place where aerobic respiration occurs. Now, they may actually assess your surface area to volume ratio knowledge within a question to do with the mitochondrion. So if they tell you that a mitochondrion has a diameter of 1 micrometers and a length of 4 micrometers, like you can see in these pictures here, then what should we do? Well, the first thing we need to do is actually cut the mitochondrion up into shapes that we can work with. Now, if we were to cut it up, what we'd be able to get is a sphere and a cylinder. So let's start with our sphere then, and let's look at how to work out the surface area and how to work out the volume for a sphere. So if we understand that it is 4 pi r squared for that surface area, we know the diameter we can see is 1 micrometers. Therefore, the radius must be half of that, which is 0.5. So then all we need to do is bring that into the equation. So 4 times pi times 0.5 squared would give us a surface area of 3.14. Now we do the same thing with our volume. We know that it's 4/3 pi r cubed. So therefore, if we substitute in our radius, we get 0.52. So now we've worked out our surface area and our volume for our sphere. Now we need to take into consideration our cylinder. So we still know that our diameter is 1, therefore our radius is 0.5. And now we need to understand how to work out the surface area and volume of our cylinder. So we need the area of a circle, pi r squared. We need the circumference, 2 pi r, and therefore the surface area is 2 pi r times the height plus 2 pi r squared. So basically the surface area is needing to add together those different numbers. So let's put in our radius and work out our area of the circle. So if we do pi times 0.5 squared, we get the answer of 0.79. And to work out our circumference, we have 2 times pi times 0.5, which is 3.14. Now we need to substitute these numbers in. So we have 3, and this is where we have to be very careful with our height. Now, when we look at our cylinder, remember we took off the 2 ends and we know the diameter was 1. Therefore, we had 0.5 off one end and 0.5 off another end. And that therefore means that our height is 4 minus the 1 micrometers and therefore 3. So don't get caught out with that part in the equation. So we need the 3.14 times 3, the height, plus 2 times our areas of the circle, which is 11. And if we were to substitute in for our volume, we would therefore get 0.79 times 3, because that is our area of the circle, times our height, and that would give us 2.37. So now we know the sphere. Now we know the cylinder, we know the surface areas, we know the volume, but we now need to work out as the mitochondrion. So to do that then, to work out the surface area to volume ratio for the mitochondrion, we need to take the surface area of our cylinder minus the area of the circles. We then add that to the surface area of the sphere, and that would give us an answer of 12.56. And then we need to add our volumes together for our sphere and our cylinder. And what do we get? We get 2.89. So now we know what our surface area to volume ratio should be. And remember, whenever we're working out a surface area to volume ratio, you always want to get the volume down to 1. 2.89 by itself, 2.89 to give you 1. Therefore, you would need to divide the 12.56 by the 2.89, which would give us an answer of 4.3521. I hope you found that helpful. And if you did, then why not join my group tuition sessions?